Class. Today we're talking about 10.8, segment relationships and circles. We have done absolutely everything there is to do with angles and circles. Now we're moving on to lengths. We'll only have one day of this. This is our only day of length. So we're just going to learn a couple of relationships that apply very generally to everything, and then we will be almost done with circles. You guys will have only one more concept to do, and it'll be taught over the next 2 days. So today, for you guys, will be Monday, okay? And we will be talking about this, and then on Tuesday, we will graph some circles. On Wednesday, we will learn how to graph different circles. So then we'll graph all the circles. And then on Thursday, we're reviewing. And Friday, there is an exam. Okay. So the exam will be comprehensive over everything we have talked about so far in circles. There's more details on Canvas if you guys are interested. Okay. So let's just jump right into this and get this done. So 10.8 segment relationships in circles. Now, the first one we want to talk about is the double interior segment theorem. Okay. So here's what I'm going to say. I'm going to draw me two interior segments. It's not that bad, right? Just any two. Any two you see fit on your paper right here. Okay? I'm going to highlight mine to be different colors. So there's an orange one, and there's a blue one. You guys see that? So there's an orange one and a blue one. I'm making that distinction because the formula I'm going to do later requires that, okay? All you need for this description over here, all you need is that two chords intersect on the interior of the circle. Two chords intersect on the interior of a circle. That's all you need for this theorem to apply. That's all you need for this theorem to apply. So if you have this, then you get this relationship we're about to write down. So they intersect here. Okay, and for simplicity, maybe we'll name this point. We'll call this E. It's not necessarily the center, so we'll just call it E. And then these guys can be A, B, right? Or let's do it like this, actually. You guys can do it however. I'll do it like this. A, B, and X, Y. Okay? A, B, X, Y. Okay. Now, here is the relationship I'm going to write down. All right? AE times EB. Okay? That's the blue line. So the blue line's pieces multiplied times the orange line's pieces multiplied. XY are segments. The orange segments multiplied. Right? Not XY, but XE times EY. Okay, so you guys see here, if I color code, let's see. My blue here are A and, B, right? My orange here are X and Y. Okay. Now, easy way to look at this is that this is the product of my blue segments, the product of one of the segments, the product of the product of the segments of one of the pieces, so the product of one of the pieces, one of these segments, I'll say that, one of the segments, equals the product of the other. Product of the other. Okay? So it doesn't really matter like which line is which. It doesn't matter like which one's going up or down or whatever. As long as you split them up by the point they intersect by, then multiply those pieces across. Okay? This looks very similar to the geometric mean idea we talked about in triangles. Okay? So think about that. This is our formula we're going to use for that stuff. Okay? The next one we have is the double secant segment theorem. The double secant segment theorem. Okay? So this is what it looks like. It looks exactly like the double secant that we talked about with angles, right? Actually, let me make these lines a little bit better. Exactly like we're talking about with angles, except now we're just talking about length. So that's really the only distinction we're making here. Let me draw it like this because it clearly doesn't want to do what I want to do. All right, nice. Now, what we can see here, if I pinch those lines out right here, that's where it's intersecting the circle, and this is where they intersect one another. So we found how to find these angles based on arc, right? Now we're going to talk about these lengths. All you need for this to occur is that you have two segments intersect on the outside of the circle. So two segments of the circle intersecting the outside of the circle. Let's think of it like a secant, right? Two secants intersect on the outside of the circle, okay? Guys, just like we did for angles on Friday, it can also be, let me write also right here, it could also be tangents, or it could be, actually, we're going to have another rule for that. I'm sorry. So we'll think about that later. The rule will be generalized later. So just now, let's think about segments. Let's think about secants, okay? So in terms of this, what we can do is we can call this, let's color these lines again just to distinguish what we're doing. Orange, there's blue. Right here will be my A and B. All right, here will be my X and Y. And then this guy will be their point of intersection, so E. I'm just going to call that E, okay? What we see here is a very similar thing, except it's just a little bit different, okay? Now, I'm going to multiply AB. Okay, so AB times, except now I want the whole line. Okay, so now I want the whole line. Look at this. This is where it's different from last time. Now I want AE. Okay, that's equal to, so if I write this, maybe this is the orange side. There's my AB, there's my AE. Okay, now I want the same thing for this other line. I want XY times XE. XE. XE is this whole segment, right? You guys see that? The whole blue line. So XY and XE. Okay, so the way to think of this, the easy way to think of this is, okay, let's think of this like this. Inside times total is equal to inside times total. Inside times total right here is equal to the inside times the total, okay? The inside times the total. Exactly. This AB times AE, XY times XE, okay? So here's what we're looking for down here. Piece by other piece equals piece by other piece. Okay, do you guys see this? Except in this case, in the bottom one, on the bottom one we want this, okay? On the bottom one, the general rule for this one is here. Okay. The general rule for the top one is up there. Let's just get us to think about it now. On this next one, this is the double secant segment theorem. Actually, it says that. I don't think it's supposed to say that. No, and for some reason it doesn't say that on here either. This is not supposed to say that. This should say, in your notes, it says this, but it should say the secant tangent theorem, okay? Secant tangent theorem. So let's erase this. If you have whiteout, it'd be best. I don't know if you guys have whiteout. But what we can do is I'll just scribble over this in white. This is supposed to say the secant tangent theorem, so that's what we'll write here. The secant tangent theorem. If not, you can just scribble it out and write it up here somewhere. Okay, that's fine. That's totally fine too. The secant tangent theorem. Okay, as long as we know they're different. As long as we know they're different, it's not a big deal. Okay, so this one occurs when a tangent and a secant intersect on the outside of a circle. Okay, so when a tangent and a secant intersect on the outside of a circle. So one of them is a tangent. So it touches at only one point. That's that guy. Okay, and then the other one is a secant. You guys see this? The other one is a secant, just like that. Okay. Now what we're gonna get here is a very similar idea. Okay. On the secant, I want the same thing I had last time. Okay. Actually, let's write down what we did first. So first of all, it's a tangent and secant intersecting on the outside. On the outside. Okay. Cool. Now, same idea. I want, I'll call the green one here, and then this orange one will be here. Okay, now, for the secant, I want the same exact deal. So in orange, I'm going to come over here. Let's call this A, B, and we'll call this point up here E. Okay, and this point can be X. Okay, just X. Now, what I'm going to do is I'm going to think of it like this. Okay, I still want the same thing. I want AB here, AB times AE. Okay, so notice, this is like we did last time. Okay, I want the whole piece times the inside piece. The inside piece times the whole piece, okay? The inside here times this whole, okay? For XE, I don't have an inside, right? I don't have an inside, so I'm not going to multiply by 0 because that would be bogus, right? I'm going to multiply by, that would give me a bogus result. I'm going to multiply by XE by itself. Okay, so let me think of it like this. Since I don't have an inside, right? There's no inside piece. I'm making up for it by just squaring this whole piece. So here's what I'm going to write. I'm going to write XE. That's supposed to say E squared. Okay, and that's my blue term. That's my blue term right there. Okay? So, here's what I'm thinking. Now for this one, I'm thinking something like this. It's part inside, let me say this, inside times the outside. Inside times the whole thing is equal to the whole squared. Now, this is not true for the other lines. So if you do this with the secant, you'll get something wrong, right? So just be careful about whenever you're looking at this line if it says it's tangent or not, right? If it's given in the question at the point of tangency, okay? So let's work a couple examples. First of all, in your first one, cross out 15 and write 4, okay, right here. Let me get the highlighter thing. Cross out 15 and write 4, because I did that wrong. And then come over here and cross out, what does it say under it? Cross out 3 and write 6, okay? Same thing. This way is going to, the other way would give us a weird answer. So, using the theorem we just did on this first one, using the theorem we just did on the back page, here's what I'm going to say. I'm thinking, oh, I want this piece, the inside piece, and this 10 is this 10 applies to this whole piece. Okay, that's poorly drawn as well. This 10 is this whole thing. Okay, if 10 applies to this whole thing, then let's see. How can I think of this? I want my inside times my whole. Okay, so here's what I'm gonna write. On my left side, I'm gonna write. Maybe I'll get some color for us. On the inside, I'm gonna write 10. That's the inside times 10 plus 3. That's the whole. That's the whole part. You see what I'm saying? This is all of it, okay? So then I'm going to write equals, and then on the other side I'm going to have my inside part times my whole part, like I just did on this last one, okay? So like I just did on this last one. Inside part times the whole part. The inside part is 4, okay? The whole part is 4 plus x. Okay, do you guys see that? Now, to make the algebra a little bit simpler, what I'm going to do is I'm going to add 3, so 10, 13. 10 times 13 is equal to, and I'm not going to do anything to this side just yet. You want to if you can. You can distribute on both sides. It'll give you the same answer. Okay, whatever you guys want to do. I'm going to show you guys a little bit faster way. So 10 times 13 is 130, and then here I'll get 16. I'm sorry, excuse me, I don't want to distribute just yet. Okay, and this I'm going to leave it alone. Okay, oops, mine's right, plus there. Okay, now what I'm going to do here is I'm going to divide by 4, and actually this, I did something wrong. I added 3, and I was supposed to add 6. Oops, so come back up here. That's why I crossed it out, right? So I won't look at it. This side is supposed to say plus 6, okay? And then here we'll get 10 times 16, and then here we should get 160, okay? 160. Now you know why. Now you can kind of see why I didn't distribute this out. Now I can divide by 4 on both sides. So if I divide both sides by 4, see it like this. This 4 and this 4 will cancel, okay? And then here I'll get, let's see, 40 equals 4 plus x. I keep writing that. 4 plus x, okay? Subtract 4 from both sides, and then the result is x is 36, okay? X is 36. So it doesn't work because the picture is not drawn to scale, right? I messed it up. You guys know me, okay? Then on this one, this is the first one we covered. This is the first one we covered. All I want to do here is piece times piece and piece times piece, okay, on the respective lines. So what I can do to help you keep them straight is maybe like highlight one. So I'm going to highlight this one. This is what I'm doing right now, okay? On this side, I'm going to write x times x plus 5 equals, and this is a similar idea to the geometric mean, if you guys want to think of it like that, okay? I neglected the proofs again because they were just too long, okay? So in this one, we're going to do 2x times x plus 1. That's just piece plus piece. Piece times piece equals piece times piece. Now, when I distribute this guy out, I'm going to get x squared, right? X times x is x squared plus 5 times x equals 2x times x. So 2x times x, that's 2 times x, right? Let's think of it like this. We might have to show me distributing this, right? 2 times x plus, and then 2x. That's this guy, and then this guy, okay? So now, if I say 2 times x, I'm saying 2 times x squared, right? So x squared plus 5x is equal to 2x squared plus 2x, okay? So, whenever I get to this point, a lot of people get confused really quick, okay? The easiest way to do this, I'm going to show you a little trick, okay? We know, since we're in geometry, x is not 0, okay? And that's because this guy's here. You guys see this? Let me show you what I mean. Let me be right over here. So over here, we know x is not 0, okay? Because that means this segment would be 0, and that doesn't make sense, right? So we know x is not 0, so that lets us divide by x. We can divide everything by x. You can't just divide by x straight up. Like in algebra, you can't just do that straight up unless you can prove x is not 0. In this case, we know it's not 0 because we're in geometry class, okay? So x squared, let me go highlight this. X squared divided by x is just x, okay? That's my orange term right there. Okay? 5x divided by x is just 5, okay? So there's my blue term, okay? 2x, same thing on this side. 2x squared divided by x is 2x, okay? That's my orange piece. Okay, now, I'm keeping all my terms alike. Do you guys see this? All my terms are alike. On this blue side, 2x divided by x is just 2. Okay, now I have a much simpler problem. Do you guys see this? I have a much simpler problem, okay? This is a much cooler way to do this. And this kind of stuff might come up on the exam, right? It might come up on the review we're going to do because this is a good type of problem, right? Where you don't know any of the exact lengths, okay? So here what we can see is if I subtract x from both sides, like this, okay? On one side, I'll get x cancels, and then I'll have 5 left. And on this side, we'll get x plus 2. Subtract 2 from both sides to get that x is 3. Okay, x is 3. Now, does that make sense? I always ask you guys. You guys are always asking me, Mr. Shirley, is my answer right? Okay, well, let's check. I don't know. Let's check if our answer is right. X over here, this is a 3, right? X plus 5, 3 plus 5, that's 8, right? 2 times x, okay, 2 times 3, that's 6. Okay, and then x plus 1. So, 3 plus 1 is 4, okay? So, here's what we see. We know the theorem to be true, right? So 3 times 8, that's piece times piece. 3 times 8, is it equal to? We're testing. So I'm not gonna write equal to because we're testing it, right? So I'm gonna put a question mark right there. Okay. Equals, or is it equal to 6 times 4? Okay, 6 times 4. Now, 3 times 8 is 24. 6 times 4 is 24, so we know this checks out. Look at this. We get a solution we know works. That's proof. That is a proof that the x that I got solves the equation. If you plug this in and you get like 24 equals 36, then you've done something incorrect. You know your x is wrong. Okay, this is the way that I'm talking about when I talk to you guys in class, that math is confounded upon principles which cannot be false. Okay, so if you plug this stuff in and you check it, you know if your answer is right or not. Okay, so moving on to this one. This is the last theorem we just did. All right, here, this side is blue. We'll call this side blue. We'll call this side orange. Okay, what's going to end up happening is we're going to have this side here squared equals the other side times the whole. Okay, so let's do the secant first. Let's do the orange side first. I'll make a big orange blank for us right here. Okay, so what we can do is we can write 4 the inside times the whole thing, like we did. The inside times the whole thing is 9 plus 4. You guys see that? Okay, now here's my blue piece. I'm going to put it right here. Okay, I'm going to get x plus 1. Keep those parentheses on there. We're talking about this as a whole number, okay? Squared. All right, now when I come down here, I'm just going to do some algebra, okay? 9 plus 4 is 13. 13 times 4 is 40 plus 24. Is that 54? I think that's 54. Wait, that doesn't make sense. It should be 52, right? Should be 52. Okay? So 52 equals, and then here, guys, don't expand this out. Don't expand this out unless you have to, right? Don't do extra work, okay? I'm just going to leave this like this. Okay, I'm just going to leave this like this. Now, I can take the square root of both sides. You guys see this? I'm going to do this in blue so we can see. Take the square root of both sides, okay? Now, there's an invisible 2 here. Okay, so these guys will cancel. And then what we're left with is 52 equals, that was a terrible, terrible 5. 52 equals, and then here I'll get, root 52. Root 52 equals x plus 1. Look how much easier this is. X equals, and if you want to just put this in the calculator, you can, okay? If you want to put this in the calculator, you can. X equals root 52 minus 1. So just to simplify 52, we know, because that's how we multiplied it, right? We said it was 4 times 13. So we already know this is 4 times 13 from earlier, okay? Which is just, and if we come up here, well, I don't have a lot of room. Okay, let's just write, maybe we'll squeeze it in right here if you guys can still see this. I'll zoom in. Okay, and we get that x is, let's see, square root of, 2 root 13 minus 1. Or you can just plug this in the calculator, okay? As long as you're doing the process right, I don't care. Plug it in the calculator, okay? So, that's it for today. That's all you guys have to do. Get started on your homework. It's not that long. You guys can work together, talk to each other, text one another, whatever you got to do, okay?